crunching chip. Hello there, my name is Andres from New Mexico Rocketry Reviews, and today we are going to be making a fully wireless launchpad that has continuity. So, let's get started. Alright, so as I said in the intro, in this video we're going to be building a wireless launchpad that does have continuity. If you don't feel like you need a continuity checker, check out our previous video in the upper right hand corner. The advantage of building the other one is that it is a bit simpler and a little bit cheaper as well. But if you want to have that continuity, keep watching. This wireless launch system will have the same features as the previous one, except now it will have a continuity checker, where you can simply hold a switch on your radio and it will beep within a few seconds if you have continuity. The previous features that were on the other one and are on this one as well include voltage to know when your battery is running low, a system so that if the radio disconnects, it will prevent it from launching, so basically a fail-safe system. And also it has an LED and a button so that you know when it's turned on, and also an easy way to turn it on. Alright, so quick disclaimer, we are not liable for anything that may happen using our wireless launch system. The other thing is that if you do not already have an FrSky Taranis remote control system, this may come out a bit more expensive than another wireless launch system, so it may not be very cost effective. However, if you do have an FrSky radio, this is a great way to save money on a wireless launch system. This doesn't mean that you can't build it if you don't already have an FrSky radio. It just means that it may be a bit less cost effective to do so. So the parts you're going to need for this wireless launchpad is you are going to need 3 Turnigy receiver controlled switches, a set of launch wires. You can just cut these off of a wired launchpad and that'll work just fine. That's what we recommend you do. You're going to need an on and off button, an LED, a voltage regulator, and we have a specific one we have, and you're going to need a battery solution. So what we have been doing is we have been using 9-volt batteries, so you can wire up around 4 9-volt batteries you usually need, or you can also use a LiPo battery. We would recommend using a 2-cell LiPo battery, so like 2S and then probably like 2,000 milliamp hours, something like that would also work very well. And the other thing you're going to need is you're going to need an FrSky remote controller. Now, the FrSky remote controller we have uses the ACCST protocol. So if yours uses ACCST just like mine does, you're going to need to get an ACCST receiver. However, if you have one of the newer Access protocol radios, you're going to need an Access receiver. We are using ACCST parts, so if you don't have any of these, you can just get the same ones we do. All of these parts will be linked down in the description. Alright, so this is the wiring diagram for this wireless launchpad. So basically we have a button, LED, voltage regulator, 3 Turnigy receiver controlled switches, and a receiver. Now as you can see, some of the receiver wires aren't super clear about where they go, so I'm just going to show you in person in just a sec here. So for the launch wires, you can see they connect at the top. You can just hook up a nice long wire with some launch clips so you can connect it to your rocket. And for the power source, there's a couple different ways you can do it. One way we have done it in the past is we have used 4 9-volt batteries, and the way you want to wire those 4 9-volt batteries is so that all the positives of the 9-volt batteries go to the positive, and all the negatives of the 9-volt batteries go to the negative. So that's how you would do the 9 volts. But the other way that you can do it is you can also use a 2-cell lithium polymer battery. We will leave a link in the description for the LiPo battery. And yeah, let's take a look at some of the more complicated electronics here so you can see exactly how to wire those up. Alright, so there's a few wiring things that I didn't show you guys or couldn't show you guys in the diagram. So now I'm just going to go ahead and show you guys here in person. So first of all, we have our various Turnigy receiver controlled switches. What I did is I just went ahead and put duct tape on them so I could label them, and that's 1 in the diagram, and they're labeled based on the diagram. So the diagram had 1, 2, and 3. Now as you can see, there's a servo wire output there, and I also have the things labeled on the end, and that's what I'm going to show you guys right here in just a second. Yep, there we go. As you can see, the wire number 2, or the one, oh, let me get that in focus. Just give me a minute. Oh yeah, I think I have to zoom in. There we go. Alright, so as you can see, the turn G receiver controlled switch number 2 is wired right there on the top left with the black wire on the inside, and number 3 is wired just next to it, also with the black wire on the inside, and that's how you want to wire that one. And there's also one on the back. I'll show you that in just a moment. Yep, there we go. As you can see, that one is the one that was labeled number 1 in the diagram, and as you can see, we also have the black wire going on the inside. That's very important. And the other thing is, as you can see right here, I didn't quite show you guys the wires, the other wires, so you can see there's the black wire and there's the red wire. Those you just wire to the power, and then there's the green wire in the diagram. The green wire in the diagram is just 1 wire over from the red. The other wires I cut. There's the wire in between the green and the red is the yellow wire. You can just cut all of them except for the black and the red wire, and also the green. Alright, so now you have finished making your electronics. Now what you have to do is you have to start setting it up with the remote controller. So the first thing we're going to do is make a model in our remote controller and bind. So what we're going to do is we're going to click the 3 lines button right here in the middle, and that's going to take us to our models. And I already have a bunch of models. If you don't have a remote controller, you're not going to have any models, and you can do this on model 1. So I'm just going to scroll down to my first empty model, and that's model 8 for me. If your remote controller is new, it'll probably just be the first one. So I'm just going to click on the 8 here, and then it's going to say create model, and you want to click on create model. And it's going to click loading model, and then it's going to ask you to select model type. Rather than selecting, just click exit, and then it's going to say model 08 or 01, whatever it may say for you. So then what we're going to do is we're going to page over here, and then now you can name your model. So just click here, and then you can scroll through the numbers so you can name it. I'm just going to name mine launcher number 2. Alright, so now that we have that named, we're just going to go ahead and start. Oh, one sec. We have to, after you name it, you have to click exit so that you don't keep typing letters. And so we're going to scroll down, and we're just going to scroll down and keep scrolling down. And then we're going to stop. Here we can stop at switch warning. So what this will do is won't let you power on your radio if this model is selected, if certain switches are flicked. So we want that off, so we're just going to click on. When you click on it, it will change the arrow, and you want to make it so that there aren't arrows, because you really don't need any switch warnings for the way we're setting it up. You just don't need them. So we're going to keep scrolling down, and now we want to scroll down to bind. So this is the binding area, so we want to set the mode to D16, and once you've set your mode to D16, it should be on default to mode D16. It'll say channel range, just leave it how it is, and then RX number, and then there's a little bind button. So the first thing we want to do is we're going to take our receiver here, and what we're going to do is on the receiver, let me zoom in for you guys, there's actually a little button here, and it's right there. So what you're going to do is you're going to use an X-Acto knife or something of a sort, and you're going to want to hold down the button while you power on the receiver. So hold the button down, and I have the button here, and I'm just going to power it on. And by powering it on with the button held, we have put into bind mode. So now what we're going to do is on RX number, let me put that back in frame for you, it'll say bind. So we're just going to click on bind right there. And it'll say channel 1 through 8 or 9 through 16. We're going to do channel 1 through 8, tell them on. Just click right there. And it's going to start beeping and stuff. And if the LEDs on your receiver have changed, that means it should have worked. So if you've done that for a while, just click exit and it'll stop beeping. And then what you want to do is you want to take your receiver, power it off so to make it exit bind mode, and then just power it back on. And this time it should show a green light showing that it has connected. So that means you have successfully binded your receiver correctly. So it may say telemetry lost and stuff like that. And it will say telemetry lost and telemetry recovered if the receiver and the remote controller are too close. So we're just going to turn this off for the time being because we are not going to be needing it. So the next thing that we're going to do is we are going to set our failsafe. So it's right underneath the RX number. It'll say failsafe. And right now it says not set, and we want to set it. So we're going to click here, and we're going to scroll down to custom. Right there, custom. And then after you put it to custom, there's a little set button. Just scroll over to set and then click on set. And then it'll say the fail-safe settings. And so what you want to do is just go to channel 1, click on channel 1, and scroll it all the way back. Just like that. Go to channel 2, scroll it all the way back. And then go to channel 3 and scroll it all the way back. Just like that. And once you have scrolled them all the way back, you have successfully set your fail-safe. So that's awesome. Alright, so now what we're going to do is we're going to start setting up our channels. So the channels are actually fairly complex, so let's go ahead and get started. So first thing we're going to do is 3-line button again, and we're going to page over, and the first place we're going to go is we are going to go over to logical switches right here. So we're going to click on logical switch 1, and it'll say edit. We want to click edit, and for function we want to set it to A is less than X. Alright, and then for V1 we are going to set that to the rudder channel. So just scroll over to the rudder channel, and that's the one you want to set it to. And then for the V2, we want to set that to like -95, something around there. And that's going to make it work the most reliably. Just put it to -95. And then there's a little AND switch button, and we need to click on that. And then once you click on the AND switch button, let me zoom out for you guys. You want to flick this switch right here at the top. It's the temporary switch on this controller. Once you flick it, it should have the SH with the down arrow. So I'm going to click exit here just for a sec so it stops flashing. And now, whenever both of these switches are held, this to the side and this one up here, the LO1 text right there at the top goes bold. And that means our logical switch is in fact working. So that's our logical switch for our ignition sequence. However, we also need to put a logical switch for our sequence so that it will check the voltage and make sure there is continuity. So for logic switch 2, it's basically going to be very similar. It's also going to be A is less than X, and it's going to be rudder once again. And we're going to once again set it to -95, just like that. And this time we're not going to put an AND switch. This time we don't want it to have an AND. We just want to have it with just this switch. Alright, so next thing we're going to do quick is we're going to page over to special functions. And we're just going to click here. And the first thing you'll do is once you turn the dial, it's going to put override channel 1. And that is basically what we want, except the first thing we're going to do is we're going to take this switch and we're going to change it to logical switch number 1. Just like that. And then override, and we want to set it to override channel 2, just like that. And then we are going to, for the value, we're going to put, let me zoom in for you guys. We're going to put -1, oh, sorry guys. We're going to click there, and we're going to scroll all the way back to -100, and then just click the check mark to engage it. And now we need to set our channels. So, oh, looks like we somehow put that to 150. It only needs to be at 100. There we go, just like that. So now what we're going to do is we're going to page over, just click page, and we want to go to our inputs. So right now we have aileron, elevator, rudder, and throttle, but we don't need any of these. So we're just going to hold down and click delete, just like that. Hold down here and click delete. Oh, just like that. Hold down, click delete, and just do this for all of them here. Bam, just like that. So now for input number 1, we are going to set that to our logical switch number 1. So for input here, that's the name. So we don't really need to name the input. It's really not all that important. So what we really want to do is we want to scroll down to source. That's very important. So now we're just going to scroll over until we find logical switch number 1. Bam, just like that. Logical switch number 1. And for channel number 3, we're going to scroll down to input number 3. We also want to set this source to logical switch number 1. This is because we need 2 Turnigy receiver controlled switches to change when we ignite, and that's how it works. So we're going to exit out again, and for input number 2, we want to set it to logical switch number 2 this time. So a little bit different, but very similar. So as you can see here, now we have it at logical switch number 1, 2, and 1, just like that. Alright, so just quick guys, before we get to the next step, I have had some very strange problems where after I change the inputs, it will change up my logical switches for some reason. So, for example, what would happen for some reason is it would change it from the rudder to channel 4 for absolutely no reason. So just after you change your channels, just go back to logical switches and go ahead and check and make sure these are both still set to rudder. So just letting you guys know about that. Alright, so for the next step and the most complicated, the first thing that we're going to be doing is we are going to turn on our thing. And we just need to have it on. And the other thing we need to do is we need to have our launch clips connected together. And then what we're going to do is we're just going to move that to the side. We shouldn't need to touch it anymore. So now we're just going to zoom back in for you guys. And if we're on logical switches, we want to page over to telemetry, which is on page 11 out of 12. And we're going to scroll down to discover new sensors and just click discover. And it should discover 3 sensors. So once it's done that, just click stop discovery. And now as you can see, we have a bunch of sensors here. So as you can see, we have 3. The first one is A2, which is basically the voltage that the clips are measuring. So actually, A2 is basically what measures whether we have continuity or not. However, it's always miscalibrated. The RSSI is the signal strength between the radio and the device. And RX battery is the amount of battery the 9 volts have. So as you can see here, they're down to 7.1 volts. So the A2 sensor is always miscalibrated. So what we're going to go ahead and do is we're going to move this switch to the side and see what changes about A2. So right now it's at around 12.9 and 13 volts. What happens when we flick it to the side? So as you can see, when we flicked it to the side, it definitely went up to around 13.1 and 13.2. And now, very strange, it will sometimes, I've noticed, do some strange drops whenever I move the switch. So right now it's at 12.9, and when I flick it, it goes up to 13.1. When I let go, it goes back down to 12.9. What we're actually going to do is we're going to go into this sensor, and sometimes you just want to increase the precision. I like putting mine up to 0.00. It'll give you a more accurate number. So right now it's at 12.95. Flick the switch and it goes up to 13.2. Let go and it'll quickly go down to a weird number, but then it goes back to a normal 12.96. So what we're going to do is we are going to create a logical switch for this. So what we're going to do is we're going to click exit and page over to logical switches, and we're going to make a new switch under logical switch 3. And we're going to click edit, and we're going to do A is greater than X. And just so you guys know, different people's receivers may be miscalibrated in different ways. So maybe for some of you, it'll be a different voltage, or maybe it'll go down when you hold the switch. If the voltage goes down when you hold the switch, you want to put it to A is less than X instead of A is greater. Those sorts of things. You just kind of have to think about it and kind of use your head and not just blindly follow this tutorial. So, but for me, it's A is greater than X. And for V1, we're just going to scroll over, and eventually we will find our sensor. Eventually, it's somewhere in here. It's usually towards the end. It's probably going to be A2. So just click on A2. And we noticed that it was around 12.95 whenever it wasn't flicked. But when we did flick the switch, I found it to be around 13.1 or 13.2. So I'm just going to set this to 13.05. That's what I'm going to set it to. Just, you kind of want to set it somewhere in the middle. That way, in case it gets a little bit miscalibrated or just changes from time to time, you want it to still work well. So we're just going to go ahead and set it to like 13.05 or 13.07, something like that. So now we have a logical switch. And so to test it, we'll flick our switch. And you'll see it'll go bold, which means it's true when we hold the switch, and when we let go, it's no longer true. So that means our switch works correctly. So that's a good test. Just connect your clips, turn it on, and if it goes bold, if the text goes bold here when you flick the switch and goes away, doesn't go bold when it's not flicked, that means you have calibrated it or set it up well. So now what we have to do is we have to make something happen with this logical switch. So we're going to exit and page over to special functions once again. And for here, we're going to put it logical switch number 3 because that's what we set it to. Okay. Let's go find. There it is. Logical switch number 3. But instead of having it override the channel, we're going to click here. Instead, we want to have it make a beep noise. So that's going to be under play sound. And you have various different beeps that you can set it to. And what this will make it do is it'll make it beep when I hold the switch. Let's go ahead and test out what this beep sounds like. I think that sounds pretty good. So now it will beep whenever you hold the switch, which is awesome. That means you have your continuity working well. One other thing that I personally like to do, but is not necessary, is you can go here, scroll down to the next one, or actually we have to click exit first. Scroll down. I like to go to logical switch 1 and make it beep whenever you initiate the launch sequence. I personally like doing that. I just think it's nice. I think it's cool to make it beep whenever you launch. And I like to set it to a different beep. So yeah. And one final thing, this isn't necessary, but I think it's really nice. So I like to have it set, is I'm going to page back over to logical switches. And what we're going to do here, this is not necessary, but personally I really like to do it, is I will make it so that my remote controller will beep whenever I run low on battery. So for function, we'll just do A is less than X. And then for here, we want to set the input to our RX-BT, which is our RX battery. So usually I have to scroll pretty far to find these things. So yep, we found our A2, so it's almost there. RX-BT, right there. That's what we want. RXBT. So now we can set a voltage that you want it to go low at. These are 9-volt batteries, so I think they're pretty much bad by like 6 or 6.5 volts. So I'm just going to go ahead and set mine to 6.3. So whenever the battery drops below 6.3 volts, the logical switch is going to become true. So now what we're going to go ahead and do is we can go over back to, or page back over to special functions. Go ahead and put logical switch 4 this time. And now we can just make it play a different sound, different beep, whenever our battery starts running low. Like, we can put like a siren or a bunch of stuff. I'm just going to put warning number 1. And then this little dash over here is also useful. So I'm going to go ahead and set it to 60. And so basically what this is going to do is it is going to repeat the beep every 60 seconds, which is useful. That way if it beeps once, you don't forget or not notice the first time. So yeah, now we are done with setting up our radio. Alright, so I know this was a very complex and advanced tutorial, so if you have any questions or you're having any problems with your wireless test system, just leave it down in the comments, and we will make sure to reply to your comment. Also, make sure to like and subscribe to help support us, because at 100 subscribers we are going to be doing a weather balloon series, so stay tuned for that. Also, check out our Facebook, Patreon, and website for more Rocketry content. And as always, other than that, have a great day.